Okay, for your first lab, we're going to learn how to turn on the robot, move the robot, and stack some blocks. Okay. I want you to get a lot of practice at this because moving the robot is 50% of robotics programming. At first, it may look a little overwhelming because the way we're going to do that is with the pendant, which is essentially a remote control for the computer that controls the robot. Alright, first thing you gotta do when moving a robot is make sure that it's on. Double check that it's plugged in. Sometimes people move robots. If the controller is not turning on, make sure that it's plugged in. Alright, so pretty sure mine's plugged in. What we're going to do is we're going to go over here. I'm going to put it on the other camera so you can see a little bit better what's going on. You're going to get down and you're going to find this little switch right here. And it is backwards as all get out. It doesn't look like a power switch, but it is. You're going to flip it up until you hear it spring to life. When you get done, you will flip it down to make it spring to dead. This is the fourth time that I got in the middle of a lab and the phone rang. So instead of stopping and starting over again, I'll call them back. Okay, so the number one thing that you need to realize when you're getting started with robotics programming is the fact that you do not have to look this cool to do it. You do need your proper protection equipment, but pizzazz is probably all genetic. Alright, so now that you got the controller on, you'll hear the fans blowing. What you'll do is connect your pendant to the controller. Okay. The robot can be controlled by a bunch of different things. Another computer, another controller from another robot. But we're going to have to let that controller, the controller is a little computer down here, know what is going to be giving it commands. We've got pendants plugged in, but we need to let the controller know that they're there. So what you'll be presented with is a screen. It says, press connect to FS100 button to establish communication with the controller. This is a touch screen. I will touch that and it will tell me that I need to grip the enable switch to confirm, and then after a second or so it'll say release it. If I don't do it in that amount of time when it tells me to, it'll say that I cannot find any connectable controller. It's not that big of an issue. One issue you will need to learn is the fact what the enable switch is this little switch right here. We called it a dead man switch, but that sounds too scary. So nowadays they call it an enable switch, which is a lot harder to say than dead man switch. It is there so that if you're programming that robot and you have a problem, that the robot stops doing what you're telling it to do. So if you drop it, the robot stops. If you have a heart attack and you squeeze it too hard, the robot stops. So that's one of the key things that we need to know about this. This is made so that only people who know what they're doing use it. Somebody jumps in and they're like, I know a dead man switch, I'm going to hold this down and play with the robot. If you hold it down too hard, they're going to think you're having a heart attack and they should probably stop. So there's an intermediate step in there. You push down and it'll engage. You push down too hard and it will disengage again. The spring in there is perfectly calibrated, apparently, so that you don't have to sit there and squeeze hard while you're programming. Adjust the strap so that it fits comfortably on your hand, and the weight of the pendant should overcome the strength of that spring just enough to enable it. Okay? Now there are two buttons there, so if you lay this down somewhere and only one button is pressed, it's going to fault out after a while. Or if you push down the other button, it's going to fault out. It wants, equal pressure. So they don't want it, laying down on something getting pressed by accident. Okay? So gentle, smooth pressure. It's not much to enable it. Okay? So we'll get back. We'll say, okay, you can't find the controller. We're going to try again. So once you push OK, you'll be presented with that screen again. You'll press connect to FS100, and it's going to tell you, grip the enable switch, let it go, and if you do it right, it'll start booting up. Now, that does another thing that's pretty important. That lets the controller know that there is a dead man switch on there. There is an enable switch that is working. So, if it messes up, we'd much rather it not work than not be able to stop the robot. Okay. So, we'll go over this pendant for what we need today. You'll have a key right here, and there'll be a teach, play, remote. Teach is where you want it to let the robot learn. When you let the robot learn, you want it to go over and over again. You don't want to have to sit there and move the blocks yourself. What you're going to do is when you're done, you'll turn it to play and play the program. If you want something else controlling the robot, like a different computer or something, you turn it to remote. For the stuff that we're going to do today, you're going to turn it to play, so that the bottom of the key is on play. Teach. We're letting it learn how to do stuff, so teach. Okay. Now, if I pull the enable switch, nothing happens. Okay? What I have to do is I have to turn the servos on. So I see this big thing that says servo on, and I start trying to push it, and nothing happens. The servo on thing right here is a light to let you know that the servo is on. You will want to push this button called servo on ready. When you press that, you'll get a blinking green light to say that they're ready to turn on. So that's the first thing you do. Then you grip the enable switch, and you should be able to hear the servos turn on. You'll hear a little whine. Okay, the brakes release and the power gets put on, and it's held up by the magic of electricity. Now, when you let go of the enable switch, the green light start flashing again, saying it's ready, but you'll hear the brakes boop, stop it again. So it's not being held up by the magic of electricity. Okay, so now you've gotten this far. You're able to make the robot make noise. Now we want to move the robot. All right, so to start with, you need to know why we move the robot. We want to go pick up a cup of water and not have it spill. Let's say that we use our arm as a good analog for that. If I use just my elbow to pick up that water, eventually it's going to spill. So what our brains do is we think about that point in space and what we want it to do, and we automatically get our joints to do things to counteract one another so that it happens, as opposed to me physically thinking about picking up my drink. Oh, look at there. I think I need this to go perpendicular to the ground. So it's a little bit of my elbow, a little bit of my wrist, and now my bottle is going up, pretty perpendicular to the ground. If I was to do nothing but use my elbow, eventually my, sweet Diet Mountain Dew will spill out if I didn't have the lid on it. Okay. So that's called inverse kinematics. What kinematics is a study of, let's say, angles. And if I have an angle going here and then going there, like, where is this point in space? So finding that point in space. Inverse kinematics is, I've got a point in space, let me find the angles that are needed to get there, okay? So what we're going to do is, sorry about that. Kinematics is going to get us to move, and it's going to dictate where that point goes. Inverse kinematics is looking at the point as being more important and the joints not being as important. So if I want to pick up something with the robot, back in the day, I had to go figure out, okay, well, I'm going to move this joint a little bit, and then I'm going to have to counteract that by moving this joint a little bit in the opposite direction. Nowadays, we're able to move the point and say, I want this point to go perpendicular to the ground, or I want this point to go parallel to the ground. And the math inside of it, the inverse kinematics, is a big word for nothing really that big of an idea. It says, I don't care what the joints need to do, I need this point to move. And that makes programming it a lot easier. But there are some places that you can't really manipulate around without going into joints. So you're going to learn how to do it. Okay. So joint movement. We've got to learn the joints. On KUKA and ABB and all these, they have what's called 1, 2, 3, 4, 5, 6. And you start with what's called a major axis, and you usually might, on an anthropomorphic arm, have 3 major, real powerful axes. That would be called 1, 2, 3. And then you'd have 3 minor ones, 4, 5, and 6. Yaskawa is the odd man out, and they have what's called Slurbit. And it's extremely hard to say when you have a list, but Slurbit is S-L-U-R-B-T. Now, it helps, and you might as well learn it anyway. So your S joint is your 1 joint. And that's a big motor down here that swings, okay? So it'll rotate, and we can move that robot, all at once, rotating up there. The second joint is L for lower. On this H casting right here, you got 2 joints. You got a lower and an upper. So you got LU. Then you got R, which, it rotates. Then right here you've got a B, which it bends, like the flets of a wrist. And then you've got a T joint, which is for tool or twist. It's best to just kind of think of twist, okay? So we can spin the end of arm tooling. All right, all your robots are going to have multiple joints. Back in the day, we had to move those joints to make something work. And we do have a way of doing that. So when we turn on our servos, we make sure this green light's on. We pull this dead man switch. It goes solid. And if you look up here, the second icon has what looks like a Tyrannosaurus Rex, but it is a robot. and that is joint coordinates. And what that does is it allows these 6 buttons right here. So you got sits on this side, to control, these 12 buttons to control the 6 joints. You've got positive and negative movement on S. You got positive and negative movement on L, and you just go through. Now the big letters are X, Y, and Z. We'll get to that in a minute. Okay, so what I'm going to do is I'm going to start moving in S, L, U, R, B, T. If I move S positive, nothing happens. Or it doesn't look like nothing's happening. But it is. What's happening is I've got in super slow mode. So if I have this little triangle right here in L, things are going to move slow. Now, slow's not always bad. You go fast, you get somewhere quick, but it's hard to get precise. So you're going to use this fast and slow button a lot. You're going to use fast to get somewhere, and then when you get close to something, you're going to slow it down so that you can get precise to it, okay? So the first part of the lab, I want you getting used to these joints and what they do for you, okay? Now, these robots are small, but they are dangerous. Like, do not get it outside of its work envelope, but get to know those joints. Like right now, I can, find S, L, U, R. Let's get it down into frame a little bit. R, B, and T, which is our final little twist joint. You're going to learn how to do that. You need to be able to move that robot. All right, so when this right here, this little icon is on what looks like a dinosaur, it's a little robot, we are in joint movement, okay? So these buttons move the joints. Okay, now we've got our robot in a pretty twisted up situation. So what you'll want to do is you'll want to go here to robot. You'll want to go over here to, let's say, second home position, right here. Click that, and you'll get presented with the screen with a bunch of numbers. Those are numbers that represent where each one of those encoders are for those motors. They are not where they're supposed to be if we want to be home. Well, if we're on the screen, we can turn on our enable, and we can push this forward button right here, and the robot's going to go back to a home position, okay? Now, second home is where we've got the suction cup as, the important end of arm tooling. For us today, let's actually go to that first work home position right there. And you'll notice that all of the numbers are 0 other than that bend. And it's a negative 92,000. That is the difference between the suction cup being down and the gripper being down. So as we push forward, it's going to start moving toward that position. And you'll see those that current position start moving toward that. And when we get all the way there, all of our numbers should line up. Okay? All of the joints are at 0 other than the bend. And we put a 90-degree bend on it so that the gripper was in the right position. Okay. It doesn't matter what screen you're on at this point. Okay? Just when you need to get the robot out of some mess, go find your home position, turn on the servo, turn on your enable switch, and hold forward until it gets there. Okay? Now, We've seen that we can move the robot. It's going to be very hard to get that robot to line up to do anything with joint manipulation. So we have a new thing since the 80s. Well, it's been forever, but where it was economical to have it on a robot, where we can use X, Y, and Z coordinates. So instead of looking at this robot by itself and looking at those motors and what those motors have to do, we're going to look at the area around the robot in three-dimensional space. Okay? And what that three-dimensional space is representing is the area around that robot. If you put out your right hand and make, a thumbs up, to God, you're pointing at your friend across the room with your index finger, and you're pointing at your friend beside you with your middle finger. You've got a good way of keeping track of how that coordinate system works together. So up and down is going to be your Z component in world coordinates. Okay, so we're saying Z plus, like my thumb's pointing up, is going to be moving that end of arm tool and that tool control point that we want to move up. Our index finger is going to be our index. Okay, so wherever our origin is, if we put our right hand rule there, wherever our index finger is pointing is going to be X positive. Our middle finger is then going to be Y positive. Okay? Now, where is our point of origin on these robots? In world coordinates, it's going to be at this base. So you have your hand here, and there'd be a little point right through here. And so your X is going to go toward that door. Your Y plus is going to go toward that side. And your Z plus is going to go up. Now, that is in world coordinates. That's saying, hey, this box that it lives in, this is what we're going to call X, Y, and Z. There's nothing special about being Z going up. There's nothing special about it. We had to make a choice. Z could be off here. We're just talking about the relationship. And when we start making user coordinates, sometimes like having something parallel to the floor is not the best case scenario. Let's say that we needed to weld a piece that was at an angle. Then we might make a coordinate system where our, X and Y are at an angle so that we can easily maneuver around that piece. Okay? So, right now, what you're going to do is you're going to go into world coordinates. We'll look here and we still see the little robot here. We go down here and where it says coordinate on the second button, we'll push it. And we'll push it once and we'll get, it's hard to see right now, but it's a little box with essentially the right hand rule. All right. So there's a bunch of different coordinate systems that we'll get to that you can scroll through there. You want to be on the robot looking icon to be in joint, and you want to be in the yellow rectangle on that second icon when you're dealing with world coordinates. All right, so when we're in world coordinates, these S icons, L icons, and U icons mean nothing to us anymore. Then we're looking at this X minus and plus, Y minus and plus, etc. We also have what's called rotate about an X-axis, rotate about a Y-axis, and rotate about a Z-axis. At first, it's going to be a little confusing because when you're rotating about an X-axis, the X component doesn't move. So put your, exploded finger gun out, and when you say rotate about X, what you're doing is you're spinning about it, okay? So play with those. When you get it completely discombobulated, go back and get it back into home position so that you can play with it some more. It's not bad to get some time on this so that you start understanding what each of the buttons do. So I'm going to rotate about the y-axis. Now we talked about the y-axis as being, left and right if you're looking at the robot straight on. Okay. Well, I'm not moving left or right when I rotate about that y-axis. Like everything else is moving around that axis. All right, now if I have to go pick up something squirrely, I might have to rotate about, let's say, the z-axis or something so that I can get around it. Okay, so whenever I rotate around the x, like x is pretty much staying the same, or it should, and the robot is moving around that point. So you can think of the end of that arm, where that tool is, as staying stationary, and you're getting the robot to work around that point. Okay, so those don't look very powerful, but you're going to use them a lot. And then you've got the left side, which is moving about X, Y, and Z in a linear fashion. So I'm going to, I still have it in the work home position. I've still got my servos on. I'm going to go down here and hold forward until my robot gets back home. And then I'm going to start moving my robot. All right, so X, I said it goes toward and away that door. Toward and away from that door. So as I do X plus, it's going to, get that tool control point to move straight toward that. And if you notice, as I'm moving this, I'm just telling it to move forward and X, and it's calculating what the joints need to do so that nothing else changes. Like if I had something being held there, it's not going up or down, it's not going left or right, it's just going forward and backwards. So it's moving parallel to the ground now. If I had a cup of water, it wouldn't spill. Well, it might, but if we get it going too quick. But it's not going to tump over. Tump is a word, I believe. All right. So Y, we said that it's moving like left and right if you're looking at it from the front. As I move, the robot is doing a whole lot of calculations to figure out what the joints need to do so that I'm not moving up and down in Z or forward and backwards in X. All I'm doing is moving in Y. Okay? And then Z. If I want everything to be the same position in X and Y, but moving Z, the robot's going to figure that out in world coordinates. Okay? So now, what we'll do is we'll spend some time, I want you to spend some time figuring out where your buttons are. You can look at them right now, but eventually you won't have to. That's why we want to get so much time on here. Now I've got it all messed up and out of whack, and it's going to be hard for me to, get, especially whenever I'm moving rotating about an axis. Well, now I want it back home. I've got my work home screen. I'm just going to hold forward, get it back there. Okay, now, when we program this robot, we want it to do something at the end of arm tooling. Now, most of your general purpose robots have no clue what's on the end of them. So there could be a welding head on here, and there'd be a bunch of functions that would have to use there that we want with the gripper. The suction cup is going to have different instructions than what this gripper will need. So there's not really a button to say open or close the gripper because there might not be a gripper attached to the end of that robot. So you'll program whatever you need to for the end of arm tooling. And if you're smart, you'll put some secret function keys so that you're not constantly having to go through a bunch of menus. We have a couple of those. We'll build some as you get better at this. But what you'll do is you'll hold interlock, which is this second purple button here. Yeah. And then period and 2, I believe for this robot, are closed and open. Okay, so we're going to send a little electrical signal out of our controller to pop these spools that are going to let air go either way to either open or close this manipulator. So you'll use interlock and 2 to close it, interlock or period to close it, interlock and 2 to open it up. Okay. Now these blocks are special. I won't say stupid, but they're not my favorite blocks. But what we're going to do is we're going to go and pick up a block, move a block, and put it down. It might seem trivial, but at the end of this, if you can pick up a block and move it and put it down, you're halfway done learning how to program a robot. The only other thing you'll have to do is tell the robot, remember this point that I put it here. Okay? So you'd go through and remember a bunch of, program it to remember a bunch of points. And then at that point, it can do it over and over again. Right now, we're just concerned with manipulating the robot. So you'll put the robot at home. You'll put a block in the middle. You'll go pick up that block. I would suggest filming it so that you can see your progression, because at the end of this, you'll feel like a robotic god or demigod, because I'm top. And you'll say none of that was hard, and I want you to be able to go back and look at the struggles that you had to do to get there. Okay, so it's not going to be easy the first time, but put time into it, and it will get easy. Okay. So joint coordinate is not going to be something that we want to use here, because joint coordinate is more complicated. Okay, so let's use the power that we have. So make sure that you're in your world coordinate with the little yellow rectangle, and just put this block somewhere arbitrary. If you put it too close to the robot, what will happen is it'll try to go down, and the joints will start getting too close to one another. So this joint has nowhere to go, so it cannot go perpendicular to the ground anymore, and it's going to beep at you, okay? And whenever it beeps at you, you're going to have to change tactics. So if you get too close to the robot, it's going to give you a hard time. You get too close to the side of the bots, it's going to give you a hard time. We'll learn how to manipulate around those, but for right now, put it somewhere, not really middle, but let's say middle of the what we would call y-axis, and then maybe right in between where the robot and the wall is. Okay, you'll go in, you'll turn on your servo, you will make sure that it's an S, Y, and Z. If you get it weirded out, go back home, but you'll go, let's see, right now I've got a hole that I need to go into and then open my gripper to pick it up. Okay, so I'm going to go ahead and push interlock and that period to go ahead and close the gripper so that I can get it in that hole. Okay, now I need to go forward a little bit, which we talked about was X. So we're going to go forward. Now if I keep going too forward, it's going to, my suction cup's going to get in the way. So I need to go down a little bit so that I can kind of get myself out of a tight. So I'm going to go Z negative. Okay. Now I've got a little bit more room to work, so I can go a little bit more out in X. Now, if I stay fast, it's going to be really hard to line up where that end of arm tooling is going to go. So as soon as I get close to it, I'm going to start dialing the speed back down a little bit. You're going to realize that in anything, like speed and precision are mortal enemies. Okay, so I'm going to get it pretty close because I know what I'm doing. But if I go too fast down and I hit that block too hard, I'm going to get it screaming at me because I crashed the robot. And hopefully we won't have to learn how to recover from that crash until at least the second lap. Okay? So now I'm pretty close to it. I'm still going to, kind of move it a little bit, but it's hard to get it perfectly lined up when I'm in, speed mode. So I'm going to dial down the speed some more. I'm going to look at it. I'm not going to get my head in that box. That's dumb. Okay? But I'm going to hover right over it, slow it down so that I'm not overshooting things. And then I'm going to go down, 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 down. I would stand up, but I'm tethered for, y'all's viewing enjoyment. While I go down into that block, I need to be real slow because if I catch an edge, then I go too fast and the robot's going to think it crashed. All right, so I'm going to go down. I'm going to keep going down until I'm right near about all the way in. Then I'm going to do my interlock in 2 again to open it. Now, since it's in there and it opens, it's going to be able to pick it up now. Once I do that, if I go Z negative, it's going to try to push it through the floor. We'll get a crash, and if it's a big robot and we're going fast, we might have to do more than just recover it, right? We'll get more into like the big idea stuff later, but be precise with what you do. Think about what you do before you do it, okay? When you get really close to the wall, don't go through the wall. Be cognizant of where you are. More importantly, be cognizant of where you physically are, not just the robot. And be cognizant of where anybody else is. Okay? So now that I'm on the table, if I go through the table, I've got a problem. So I've got to think what goes up. And that's Z plus, right? So we're going to do Z plus, and we're going to make sure our fat thumbs are on Z plus, and then we're going to go up. Now, once we clear the table and we know that we're where we need to go, then we can speed it up a little bit and get it out of the way faster. Okay? Now, what I want you to do, make sure that you have, you can video this, you can talk about it and stuff, but at least I want a picture of the block in the air. Okay? So if you're doing pictures, do a picture of the block on the platen, the block in the air, and then the block somewhere else on the platen that you put it down at. So you're going to pick it straight up, and while you have that block, what I want you to do is I want you to rotate around a few axes. Okay, so look at what the block does when I rotate about Y. Remember, Y is going left and right, but when I rotate about Y, like the block pretty much stays in the same place in Y, but then the robot is working its way around Y. Okay? So I want you to rotate about a few things and watch that block. Now, if we had the tool control point perfectly programmed on there right now, the block would look like it was just floating in air. So we'll make a better tool control point as you get used to this. But basically, you're getting the robot to work around a point in space instead of moving that point in space. Okay, so it's important that you kind of see what happens. Now, if you manipulate it too much and get it out of whack, if you're on that work home screen, just hold forward until it gets back up. you've still got the block. Manipulate it so that you see what's happening as you move it in the different planes. If you notice, as it's moving about Y, it's also twisting the block so that the block is still parallel to the surfaces that it was to start with. Okay, so, there's twist involved in that, linear move, because we're telling the robot, we want you to move that point, don't turn it. Okay? When we're rotating about an axis, we're saying rotate around that point, don't move it. Cool? Okay. So you're getting some real good meat here, but you're not having to, read 50 pages to do it. All right. So I'll probably put some firecrackers or something in here to, spice it up. But this is easy sauce. Okay. So what I want you to do, get that block up, take a picture, get it back down. Now, at first, like when you're far away from something you can hit, you can go faster. All right. But then as you get in closer to something that could cause you problems, slow it down. Now, sometimes you're going to slow it down too much. There's L for low, M for medium, H for high, and then there's something called I for inching. Now, when they say inching, they're not talking about inches. They're talking about like microns. So when you're in inching mode, you'll be like, I can't get the robot to move. And it's moving, it's just moving so slow that you cannot see it. Now, that's very important when we've got, really precise things that we need to line up. But when you're thinking that, it's going to, move a certain amount and it's not, then let's put it in inching. It's in inching right now. I can't tell that it's moving. Now, if I hold it here for a long time, I will see a difference in position. But if you think that the robot's not moving before you come bug me, make sure you're not in inching. Okay? So at least get up into low unless you're doing super precision work. All right, so now that we're in low, we're going to finish out putting that down. As soon as it touches, don't go any farther because it will register as a crash. Then we're going to hold interlocking period to close that gripper again so it's getting us out of that hole. We're going to use our brain to make sure that we're not going to go through the platen. So we need a Z plus, right? We'll push Z plus. And once we verify that that's the right direction, right? Because I make stupid mistakes too. Then once we verify that's where we want it to go, then we can speed it up to get the heck out of town. Okay? The way you're going to leave this is you're going to leave the block where it's at. You're going to turn the robot on, the servos on. You're going to forward it back home. Okay? Now, when you get here, I don't want you handling the blocks, okay? So, put the block back where you had it to start with. I'll disinfect the blocks. I'll put them in there. The person before you will pick up the block, move it somewhere else, and then move it back to where they had it originally, or pretty close, okay? So, we don't have to keep disinfecting those blocks. We don't need to disinfect the robot 50 times either because we're not going to touch the robot. Now, if the robot touches you, let me know so we can go to the hospital because, it's not supposed to. These robots can kill, okay? So what I want you to do is you'll come in, there'll be a block there, a robot there, and your pendant and power switch will be disinfected by the person that was there before you. When you get done, make sure that the block's where it was and make sure that the robot is home, okay? And then when we say it's time to go or you're done, you will go get a disinfectant wipe. You'll wipe off the pendant. You'll wipe off the on-off. You'll turn off the robot. Make sure to turn off the robot because people need to learn how to turn it on. And if you learned how to turn it on, it's real simple to turn it off. Just do the opposite of what you did at that point. Okay? Cool. So you'll wipe down, you'll turn off the robot, wipe down the switch and the pendant. You'll get your stuff and get out so that they can come in and do their work. Okay? So you'll be presented with the same situation that the first group will get. Okay? So, I know the first lab is going to take longer than it usually will after we get cooking. And I know this video is longer than I want it to be. Like, I'm working real hard to try to get them down to, 10, 15 minutes. This is 45 minutes right now. It'd help if I stopped talking. But one of the issues that I have is there's a lot of stuff to cover in the first lab that doesn't have to be covered subsequently. You'll have this video to reference. I might go through and, slice it up so that the topics are, in more easily digestible chunks. But, it's important to do these pre-labs so you know what you're going to do. And then when you go in, you'll have them to reference so that if you get into a tight spot that you can get an answer pretty quick. But if you do have an issue or something that hasn't been covered yet, grab me or Ashley and we'll get you rolling. And if you get to the end and you still need help, be it on book work or on some question that came up that you didn't have an opportunity to ask, let us know. You're going to wait until the other lab group after you gets going, and we'll come out and get you and find a disinfected place to talk. Okay, so that's what we want to do on the first lab. Hope you're having a good weekend or whenever you're watching this. But